Hi everyone, my name is Anvita Bansal and today we are going to discuss another problem from the SDE sheet, that is kth element of two sorted arrays. So let's move to the problem. You can see the problem. This is from the SDE sheet. You can access it from here. Let's solve this problem. Let me move to the question so that you can see it for yourself. Okay, so what does the problem say? Kth element of two sorted arrays you're given, basically two arrays which are in sorted order, right? Given two sorted arrays ARR1 and ARR2 of size n and m respectively, the sizes of the given arrays need not to be same, they can be different, and an element k. The task is to find the element that would be at the kth position of the final sorted array. What does that mean? See, let's move to the whiteboard and understand this one. Have a look. Let me just ensure if you can see my screen. Yes, I think you can. Fine. So if we move to the whiteboard, I've written a test case already here for you. So what you need to return? You are given two arrays and an element k. You have to return the value of kth element from the arrays such that if you merge both the arrays, right, in the sorted order, what would be the kth element? So if I merge both the arrays, you don't need to create an array, but okay, let's see here. If I merge both the arrays such that they are sorted all together, okay, then what am I going to get? Can you iterate over both the arrays with me so that we get the sorted array finally? Okay, so what should be the length of this array? What is the length of this array? Let's say that is denoted by, let's say that the length of this array is denoted by n, the length of this array is denoted by m. So what we will get, n is 3, let's say m is 6, the length of this array is 6. So what you need to draw is an array of length n plus m, right? So if I want an array of length n plus m, I am going to create the length of 9, right? This is what I want. 2, 3, 4, 5, 6, 7, 8, and 9. I can erase the rest off. Okay. Let's fill this array. Okay. When I fill it, what do I get? It in the sorted order. Okay. Let's start iterating over these two arrays and what would the resultant array such that it is sorted. So 1, this will be 1, this will be 2. Then what I should get is 5 from here, then 6 from there, 5. I hope you all are aware of how to merge the two sorted arrays. Then 8. What I'm going to get is 8. Then 13. And then because both the arrays are sorted individually, so it's very easy. Just keep two pointers, start iterating over them, compare them, and start filling it in this array. Okay, 13. After that 15, 18, and then last 22. So you already know the indices of these arrays also, right? Starting from 0th index, 5, 6, 7, 8. So n plus m is 9, which is the length. So indices will be from 0 to 8, right? You want to return the kth element. Kth element. That means if I ask you to return fifth element, so that would ideally be first, second, third, fourth, and fifth. So you need to return the element of from this array, from this ARR, let's say. So ARR of given k minus 1 is what you need to return. So what was this approach? The first approach that we discussed here is that, what is this approach? That you create another array, take some extra space, a new array of length n plus m, right? And then return, you traverse over it. How do you create and fill this array? You fill this array by taking two pointers on both the arrays. you compare them, and you start filling the array in the order of the one which is less. Let's say I is here, j is here, I is smaller than the value at ith position is smaller. I fill this index with 0. There is some, let's say I take another index which I denote with x. So x is initially at 0. So you fill x with the smaller value, that is 1. The value which you fill, the index of that array will be increased to the next position. Now you compare both. The smaller one you will fill here, and you also increment the count of x. So x was here. Now once you are filled with this, now your x will be here. You compare these two values. Okay, you already filled it. Okay, the smaller one will be moved. Now you compare both the values. 5 is smaller, so you fill this arr of x with arr1 of I, and then you increment the count of I and also increment the count of x. That's how you keep comparing and filling. And in the end, you return arr of the resultant array which you created, arr of k minus 1. Okay, so there is no problem in this approach. The only thing is we can optimize it. We can optimize this approach by taking no space, by taking no extra space. Okay, that's what I'm trying to tell you. So the second approach that we discuss here is, let's say we do not want to take any extra space. This is your second approach. And we do the similar operations. If we do the similar operations, what can we do? Have a look here. If let's say I take it and I place it here. Okay, fine. So in this one, in this array, start your iteration using 2 pointers the way we were doing. Okay, what were we doing? We were doing the same thing. One sec. Let me just clean this up. Fine. So, this is what you have currently. Now start taking the, let's take, you take I here. This is your ith index. This is your jth index. Okay, and you start your iteration. I is also initially at 0. J is initially at 0. Let's maintain a count variable which is denoted by count. Count also initially I take as 0. Now take a loop. The length of this, let it be n, and the length of this array be m. This is, let's say, arr1. This is your arr2. Fine. Let's begin the iteration. I'm writing the counts here in whatever manner I'm going to start my iteration. So you start with I0, J0. You compare the value which is smaller. Let me just once check if you guys are able to see me and properly. You can write it in the chat as well. Okay. So you start with I0, J0. Compare the values. Compare the values of I. If ARR of I is less than ARR1, ARR2 of J. If this is the case, right? If this is the case, then what you're going to do? First thing, that you increase your count. Before that, let's do one thing. If that is the case, obviously your I is going to go to 1, next point, next counter, right? And your J is going to stay there. So as soon as I make one comparison, I increase the count. Now my count will become 1. If my count becomes 1, I will also check, is this count equal to K? Is this count equal to given value K? If that is the case, then I am going to do what? Since I'm checking for ARR1 of I, this is your I pointer, checking for ARR1 of I have already incremented the count. That means that I have traversed over one element in either of the arrays, which is ARR1 here. And I find that, let's say your given k was 1 only. So your count has become 1. And which element has basically contributed to make this count 1? That is ARR1 of I, which is ARR1 of 0. So you'll return what? ARR1 of that index, right? If this is not the case, count is yet not equal to k, then what do? You increment the count of I, because what you were doing, you were checking for ARR1 of I. If that was less, so you incremented the count to this position. Your J is still at this position. Is that understood? Okay, moving to the next. Now checking the same condition for if, let's say, your ARR of J is less than your ARR1 of I. So ARR, that is basically your else condition. You don't need to write another if. You can put it in else condition. Okay. So now your J is okay. J is still here. Else what will happen? Else you see, if ARR2 of J is less than ARR1 of I. Again, that means we have found one value. And we can increment the count plus plus. Again, you check for same condition. If your count is equals to k, now what you want to return? You will simply return ARR2 of J. Why? Because this time the value which was contributing to increase your count was the value present in ARR2 of J, right? And if that is not the case, you simply increment the count of J and continue your comparison. Now your J will come here. Now tell me one thing. These counts will keep on incrementing. Both the pointers will keep on incrementing. And what should be the flow of stop for the flow? So while you have taken two indices I, it should be less than the length of this first array. I should be less than n, and also J is less than m. Only in those cases you are trying to iterate over these two arrays. If let's say one of the indices is exceeds the length of your array, then what happen? You need to handle those cases separately. How you will handle it? Look here. We will do a dry run and then you will understand. I hope you have already understood also. There's nothing much in this, only you have to handle the count and also the cases where it exceeds the length of the given either of the arrays. So let's say you were at this index. Now the comparison will be made with 5 and 6. Your count is at what? Your count is right now 1, 2, 3. Let's do the iteration again from the beginning, and then we'll write the next part of code. Okay, let's do the iterations. So I is at this position, J is at this position. And your count has become, initially it is 0. Now it will become, you compare, this value is less than the value in jth index, your count increases, and let's say you want to return your k that I'm giving you is, let it be 6. Okay, so what happens? Count becomes 1, your I is incremented, I comes at this position. Okay, now your J value at J is less than your I. So what do? You come in else condition, you increment the count to 2 now. Now you check if count is equal to k, which is not the case. You increment the count of J and J becomes here. Now you check for, you come at this condition because your ARR1 of I is less than your ARR2 of J. You increment the count to 3. You increment the count to 3. It is yet not equal to, why count is 3? Because till now we have traversed over 3 elements altogether. First we compared 1 with 2, so 1 came to be smaller, so basically I was at 1. Then 2 was compared with 5. Okay, 2 came out to be smaller. Now I'm at this index, so basically my comparison will be for the third value which I'm evaluating, so count eventually becomes 3. It is not equal to k. What do? You increment the count of I to the next index. Now what is the case? Your case is when ARR2, it will come in else condition, ARR2 of J is less than ARR1 of I. Increment the count. Count is still not equal to k because k is 6. So increment the count of J to this position. What condition should we go? ARR1 of I is less than ARR2 of j. I'm at this condition. Increment the count, make it 5. Count is not yet equal to k. Just increment the count of I and it will become equal to n. So now what happens? When it becomes equal to n, I again check for this condition of the while loop. I is not less than n, and both the conditions should be true to in order to go into this while loop. So since this condition fails, I come out of the loop. When I come out of the loop, I check. Now I will only come out of the loop only when either of the one condition or both the conditions is false. So if, let's say, I have exceeded the length of ARR1, right? That means I have to traverse over the length of ARR2. So while your j is still less than m, what are you going to do? See, your count is 5, right? Right? Your count is 5. And what element were you present at? You are checking for 13 and there is no value present in ARR1. So that means 1, 2, 3. These 3 elements we have traversed. 3 elements are done. 4th, 5th, and 6th. I am currently at the 6th value, means I am at the 6th element of my sorted order, right? And the count is still 5. And I came out of the loop because this condition failed. So I know I need to increase the count by 1 as soon as I come out of the loop, because my count is still at 5 and the value that I'm evaluating is actually the 6th element of my altogether sorted array. Although I'm not creating an array here, only the calculations are handling this thing. So I'll increase the count and check for this condition again. If your count is equal to k, now then what you gonna return? See, I am traversing for j less than m. That means I am in which array? I am in the second array. That's how I'm handling. Then return ARR2 of j. And if that is not the case, you simply do j plus plus. And right now, so coming out of the loop, my count was 5. I increment the count of 5 to 6. I check, okay, it is true that my count is equal to k, that was 6. So I'll return ARR2 of j, which is 13. My j is currently pointing to 13. So that's what I want to return, right? I wanted to return 6th element. So I am returning 13. Is it holding true? Let's check. So in your sorted array, if I check, this is 1, 2, 3, 4, 5, 6. So this is the 6th element that I'm returning, and that is ideally correct in this case. Let's say if your k was not 6, it was 7. What were you going to do? Nothing. You'll just do one more iteration in this loop. Now you do j plus plus, because you are not still returning ARR2 of j. J comes at this position. Now you check. You have already done count plus plus. Now you check, is your count equal to k? Yes, it was 6. Now it had become 7. So I'll return this array. Okay, this is the case when your ARR1, this loop I'm writing when ARR1's length is less than ARR2's length, right? That is, n is less than m. You also have to handle the case where m is less than n. That means, let's say this was your ARR1 and this was your ARR2. In that case, what would you do? You'll take one more loop in the case where what ARR2 is smaller. That means you are done with ARR2, but your I is still continuing. You want to continue I iteration. So you write one more loop, which will look something like this: while I is less than n. Okay, and again you do the same thing. Let's say you were at 7th index and I want you to return me 9th index. Okay, what will you do? You'll do the same thing. This is your ARR of 1 in this case. You are at this index and you do the same thing, just the indices would change. Count plus plus. If count equal to k, you return what? I am using I for my ARR1. So that means I am at ARR1, return ARR1 of I. This is return. Otherwise, do I plus plus. That is all about this problem. Let's try to move to the core and do it. So I discussed 2 approaches, one in which we were simply using one more array. Both the approaches are almost similar, except for one difference. That is, here we are using array to store the values literally and then returning the k minus 1th indexed value from the array, and here in order to avoid the use of extra space, I am handling that with a new variable count, which is telling me the count of element, count of that index, which is actually the index of the element if they were sorted all together in a new array. That's the only difference. So let's try and move to the code. I hope you have understood this. Fine. Coming to the code. Okay. So let's take the variables int I0, int j for the iterations 0. Then you have int count equal to 0. Now do your iterations for while I is less than your length of array and j is less than length of array 2. If what were you doing? You were checking for if ARR1 of I is less than ARR2 of j. Then what? First thing, incrementing the count variable, checking if count equals to k, return ARR1 of I, otherwise I plus plus, right? Doing the same thing if your ARR1 is less than ARR2. If your ARR2, that can be simply taken into else case. You do again count plus plus. If count is k, this time you return ARR2 of j, right? And do j plus plus. Once you are out of the loop, because of the three cases. One case, either you have exceeded the length of your array 1 and still your array 2 is remaining. Other cases, you have exceeded the length of array 2 and the length and array 1 is yet to be traversed completely. Or the third case is both the arrays are of equal length and you have exceeded the length of both the arrays. In that case, if you still haven't returned any value, you return -1. Okay, that is the final case. And for the other two cases, I am writing the conditions. While I is still less than n, I showed you that you were doing count plus plus. You remember this thing? Let me show you. So we write something like this, right? For the conditions when your length is yet to be traversed, you were doing count plus plus because I showed you via dry run. This thing you need to dry run on your own. Take one example and check why we did count plus plus in the beginning of the while loop. Why not in the end? What change, what impact will it make? It will fail for a lot of test cases, not all, but still a lot of test cases, because your evaluation calculation wouldn't be in place in that case. You try to do it on your own. Don't just see that always we are doing count plus plus in the beginning of the loop. No, try it yourself. Then you will understand. Okay, count plus plus. Then what if count is equal to k, I is for ARR1, return ARR1 of I, otherwise I plus plus, right? Do the same thing if let's say it's for j, your j is less than the length of that array, do count plus plus, return ARR2 of j, and then you do j plus plus. That is all. Let's see. That is all about this problem. Yeah, you can have a look. You can have a look at the code. It is exactly what we discussed in the pseudo code here. That is all about this problem. So it was, I would say this is also an easy question, although it is categorized as medium, because first intuitive thought could be again taking an extra space of length, array of length equal to length of array 1 plus length of array 2. store all the elements in the sorted order. There also you're using two variables to keep the track of the elements in the two respective arrays, right? Only we are eradicating the use of an extra space by taking the extra variable, that is count, in a second approach, and then we are keeping the track of the elements in the sorted order, and we are just through the index we are returning the exactly kth element that we want to return from the list of sorted array from the two sorted arrays. That is all about this problem. And since we are iterating over both the arrays in one go, so the maximum operations that can be made would be O of n plus m, right? So that is the time complexity for this problem. I hope you all have understood this, and number of occurrence problem we can take up in the another video if you want. Otherwise, I think number of occurrences should be easier now for you to solve after this problem. And that is all about today's lecture. Let's wrap it up. See you all tomorrow at 8 p.m. Thank you, everyone. Bye bye.